Now in this lecture we will find the value of x using two different methods. In the drawing we have right triangle ABC. We know that angle ABC is a right angle, it equals to 90 degrees. We also know that BD equals to 3 units, DE equals to 4 units. And we know that angle BAD equals to alpha, angle ADE also equals to alpha, and angle EAC equals to alpha also. And we want to find out the value of EC that equals to x. Okay, so first of all I will present to you a new theorem, the angle bisector theorem. What is the angle bisector theorem? Angle bisector theorem actually, if we have a triangle ABC, and AD is angle bisector. What is angle bisector? It actually bisects angle BAC. This angle, that is to say, it divides it to two equal parts. If this angle is theta, then this angle will be also equal to theta. So angle bisector AD divides angle BAC to two equal parts. It bisects angle BAC. Okay, so according to angle bisector theorem, an angle bisector divides the side that it hits in a ratio that equals to the ratio of the angle legs. So I'll read angle bisector theorem again. Angle bisector theorem states that an angle bisector divides the side that it hits in a ratio that equals to the ratio of the angle legs. So actually, what is the meaning of angle bisector theorem? Angle bisector theorem states that the angle bisector AD divides the side that it hits, angle bisector AD hits side BC and divides it in a ratio of BD over DC. Okay, angle bisector AD divides BC in a ratio of BD over DC. And that ratio equals to the ratio of the angle sides. This angle sides or angle legs are actually AB and AC. So the ratio between the angle legs equals to the ratio that angle bisector AD divides BC. So the ratio between the angle legs is AB over AC. AB over AC. So the ratio that angle bisector AD divides BC is BD over DC, and that ratio equals to the ratio between the angle legs, that is to say AB over AC. Okay, so that is angle bisector theorem. So we actually can implement the angle bisector theorem in our drawing. We focus on the right triangle, triangle ABE. On the right triangle, triangle ABE. Actually, AD is angle bisector in the right triangle, triangle ABE. AD is angle bisector. AD is angle bisector in the right triangle, triangle ABE. Why AD is angle bisector in the right triangle, triangle ABE? Because of the fact that AD divides angle BAE to two equal parts, to alpha and alpha. Therefore, AD is angle bisector in the right triangle, triangle ABE. And according to angle bisector theorem, angle bisector AD divides the side that it hits, that is to say BE, in a ratio of BD over DE. And that ratio equals to the ratio between the angle legs. The ratio between the angle legs, the ratio between these angle legs is AB over AE. AB over AE. AB over AE. So according to angle bisector theorem, the angle bisector AD divides BE in a ratio of BD over DE, and that ratio equals to the ratio between the angle legs, and the ratio between the angle legs is AB over AE. So the ratio that angle bisector AD divides BE equals to the ratio between the angle legs. Okay? And what is the value of BD? BD equals to 3 units. What is the value of DE? DE equals to 4 units. And it equals to AB over AE. Okay? So we have this equality that AB over AE equals to 3 over 4. In the next step, we will define AB as 3K. That is to say, AB equals to 3K according to our definition. And we will find out what is the value of AE if AB equals to 3K. So we will substitute AB by 3K in this equality and we will find out the value of AE. Okay, so we will get that 3 times 3 over 4 equals to AB. AB is 3K according to our definition. 3K over AE. Here we will multiply this equality by AE. And we will get that 3K equals to AE times 3 over 4. Okay? A 3K equals to AE times 3 over 4. Here we will multiply this equality by 4 and we will get that 3K equals to AE times 3, so it is 4 times 3K equals to AE. 4 times 3K is 12K. 12K equals to 3 times AE. Here we will divide this equality by 3 in order to get the value of AE. We will get that AE equals to 12 over 3 is 4. So AE equals to 4K. AE equals to 4K. So we found out that if AB equals to 3K, then AE must be equal to 4K. Okay? So in the next step we will continue to focus on the right triangle, triangle ABE. On the right triangle, triangle ABE, according to the Pythagoras theorem, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. That is to say, AB squared plus BE squared equals to AE squared. AB squared plus BE squared equals to AE squared. Okay, AB squared plus BE squared equals to AE squared. That is according to the Pythagoras theorem. According to the Pythagoras theorem, what is the value of AB? AB equals to 3K. So AB squared is 3K squared plus BE squared. What is the value of BE? BE equals to 3 plus 4. That is to say to 7. And BE squared is 7 squared. What is the value of AE? We have already found out that the value of AE is 4K. So AE squared is 4K squared. So we have this equality. Here 3K squared is 9K squared plus 7 squared is 49, all equals to 4K squared is 16K squared. Okay? So here we will subtract 9k squared from this equality, and we will get that 49 equals to 16k squared minus 9k squared is 7k squared. Here we will divide this equality by 7. 49 over 7 is 7 equals to k squared. We will take a root out of this equality and we will get that k equals to the positive root of 7. K must be a positive number because it represents the side of a triangle that must be a positive number. Okay, so we found out that k equals to root 7, but we know that AB equals to 3k according to our definition, and AE equals to 4k. So we actually can place the value of k inside this equality, and we will get that AB equals to 3 times root 7, and we will place the value of k inside this equality, and we will get that AE equals to 4 times k is root 7, so it is 4 times root 7. So we actually found out the values of AB and AE. Okay, so in the next step we will focus on the right triangle ABE. On the right triangle ABE, we know that tangent 3 alpha equals to BC over AB. Again, on the right triangle ABC, we know that tangent 3 alpha equals to BC over AB. Okay, what is the value of BC? BC equals to 3 plus 4, that is 7, plus x. BC equals to 7 plus x. And we have already found out that AB equals to 3 times root 7. So in total we got that the value of tangent 3 alpha is 7 plus x over 3 times root 7. I'll write it down. Tangent 3 alpha equals to 7 plus x over 3 times root 7. So in the next step we will focus on the right triangle ABE. On the right triangle ABE, we know that tangent 2 alpha equals to BE over AB. Again, in the right triangle ABE, tangent 2 alpha equals to BE over AB. What is the value of BE? BE equals to 3 plus 4, that is to say 7. And we have already found out that AB equals to 3 times root 7. So in total we got that the value of tangents 2 alpha equals to 7 over 3 times root 7. So I'll write it down. So in the next step we will focus on the right triangle, triangle ABD. We know that tangents alpha equals to BD over AB. Okay, tangents alpha equals to BD over AB. What is the value of BD? BD equals to 3 units. And AB equals to 3 times root 7. So in total we found that tangents alpha equals to 3 over 3 times root 7. Tangents alpha equals to 3 over 3 times root 7. So we actually found out the values of tangents alpha, tangents 2 alpha, and tangents 3 alpha. Okay? But we also know that the value of tangents 3 alpha equals actually to tangents 2 alpha plus alpha. Okay? And in order to find out the value of tangents 2 alpha plus alpha, I will present to you a new trigonometric identity. The trigonometric identity is tangents A plus B. It actually equals to tangents A plus tangents B over 1 minus tangents A times tangents B. Okay? Tangents A plus B equals to tangents A plus tangents B over 1 minus tangents A times tangents B. We will use this trigonometric identity in order to find out the value of tangents 2 alpha plus alpha. So here we have actually tangents 3 alpha equals to tangents 2 alpha plus alpha. And according to this trigonometric identity, tangents 2 alpha plus alpha will be equal to tangents 2 alpha plus tangents alpha over 1 minus tangents 2 alpha times tangents alpha. Okay, so we found out the value of tangents 2 alpha plus alpha according to this trigonometric identity. But we know that tangents alpha equals to 3 over 3 times root 7, tangents 2 alpha equals to 7 over 3 times root 7, and tangents 3 alpha equals to 7 plus x over 3 times root 7. So we can substitute the values of tangents alpha, tangents 2 alpha, and tangents 3 alpha by those values that we have already found out. Okay? So we will get that tangent 3 alpha is actually 7 plus x over 3 times root 7. That equals to tangent 2 alpha is actually 7 over 3 times root 7 plus tangent alpha is 3 over 3 times root 7, all divided by 1 minus tangent alpha, tangent 2 alpha, 7 over 3 times root 7 times tangent alpha, that is 3 over 3 times root 7. Okay, so that is what we found after we substituted tangent alpha, tangent 2 alpha, and tangent 3 alpha by the values that we have already found for them. Okay, so here we will substitute 1 by 3 times root 3 times 3 times root 3 over 3 times root 3 times 3 times root 3 in order to have a common factor with this expression. Okay, so we will get that seven plus x over 3 times root 7 equals to, here 7 plus 3 is 10 over 3 times root 7, all divided by, as I've already said, we will substitute 1 by 3 times root 7 times 3 times root 7 over 3 times root 7 times 3 times root 7. So we substituted 1 by this expression equals to 1, and then we have here this expression is actually 7 times 3 is minus 21, minus 7 times 3 is minus 21. So here we will move this expression to the numerator, and we will move this expression to the denominator here, and we will get that 7 plus x over 3 times root 7 equals to 10 times 3 times root 7 times 3 times root 7 over 3 times root 7. We'll move this expression to the denominator. 3 times root 7, 3 times root 7 minus 21. So actually we have 3 times root 7 in the numerator, and we have 3 times root 7 in the denominator. So we can cancel 3 times root 7. And what is left after we cancelled 3 times root 7 is 7 plus x over 3 times root 7 equals, here 10 times 3 is 30. In total we will have 30 times root 7 over Here 3 times 3 is 9, and root 7 times root 7 is 7, and 9 times 7 is 63. 63 minus 21. Okay. So 63 minus 21 is 42, so I write it down. 7 plus x or 3 times root 7 equals to 30 times root 7. Again, 63 minus 21 is 42. So we got this equality. So here we will multiply this equality by 3 times root 7. We will get that 7 plus x equals to 3 times root 7 times 30 times root 7 over 42. Here 3 times 30 is 90, and root 7 times root 7 is 7, and 90 times 7 is 630. (630) over 42 is 15. Here we will subtract 7 from this equality, and we will get that x equals to 8 units. So we found out that the value of x is 8 units. Okay, so we finished with the first method, and in the next step I will present to you a second method to find the value of x. Okay, so we will do here a construction. We will extend side dB by 3 units. And we will define this point as point M. We extended dB by 3 units, therefore MB will be equal to 3. And then we will connect together points A and M by a straight line. We know that MD is a straight line. Because BD is the side of a triangle, and we extended BD, so it was a straight line and it will remain a straight line. So MD is a straight line. And we have a rule that states that the sum of the angles on a straight line equals to 180 degrees. Equals to 180 degrees. The sum of the angles on a straight line equals to 180 degrees. So we know that MD is a straight line, therefore the sum of the angles at any point on the straight line MD must be equal to 180 degrees. And especially at point B, the sum of the angles on the straight line MD must be equal to 180 degrees. So which angles we have at point B on the straight line MD? We have at point B the right angle ABD, it is equals to 90 degrees, plus angle ABM, so in total the sum of those two angles must be equal to 180 degrees because of the fact that MD is a straight line. Okay, so we have this equality according to the rule that the sum of the angles on the straight line MD equals to 180 degrees. Here we will subtract from this equality 90 degrees, and we will get that the size of angle ABM equals to 180 degrees minus 90 degrees is 90 degrees. So actually angle ABM is a right angle. It equals to 90 degrees. So in the next step we will prove that those two triangles can go into each other. So we will focus on triangle, the right triangle, triangle AMD, AMB. This triangle, the right triangle, triangle AMB. And the right triangle, triangle ABD. So on those two triangles, those two right triangles, triangle AMB and triangle ABD, we know that MB equals to BD equals to 3 units. MB equals to 3 units according to our construction. MB equals to BD equals to 3 units. MB equals to BD equals to 3 units. We also know that those two angles are equal to each other. They are both right angles, so angle ABM equals to angle ABD equals to 90 degrees. Angle ABM equals to angle ABD equals to 90 degrees. And AB is a common side. It belongs to both triangles, so AB equals to AB is a common side. AB equals to AB. It is a common side. So we actually proved that triangle AMB can go into triangle ABD according to the rule side angle side rule. Okay, I'll write it down. Triangle AMB congruent. This is the sign of congruent to triangle ABD according to side angle side rule. Okay, triangle AMB can go into triangle ABD according to side angle side rule. So what is side angle side rule? Side angle side rule states that if you prove the two sides and the angle between them in one triangle are equal to two sides and the angle between them on the other triangle, then you actually proved that those two triangles can go into each other according to side angle side rule. We actually proved that those two sides and the angle between them in the right triangle ABD are equal to those two sides and the angle between them on the right triangle AMB. Therefore, we actually proved that triangle AMB can go into triangle ABD according to side angle side rule. Okay, so from the fact that those two triangles can go into each other, we can conclude that those two angles are also equal to each other. Okay, angle MAB in triangle AMB is equal to angle BAD in triangle BAD according to the rule that corresponding angles in congruent triangles are equal to each other. Those two triangles can go into each other, therefore the corresponding angles are also will be equal to each other. Okay, so angle AMB equals to angle BAD according to the rule that corresponding angles in congruent triangles are equal to each other. Again, triangle angle MAB equals to angle BAD. Those two angles are equal to each other according to the rule that corresponding angles in congruent triangles are equal to each other. And we know that angle BAD equals to alpha, so angle MAB must be also equal to alpha. Okay? Angle BAD equals to alpha, so from this equality we can derive that angle MAB also equals to alpha. Okay, and we also can conclude from the fact that those two triangles can go into each other that AM equals to AD. AM, side AM equals to side AD according to the rule that corresponding sides in congruent triangles are equal to each other. Those two triangles can go into each other, therefore the corresponding sides, that is to say AM and AD, must be also equal to each other. Okay, so AM equals to AD according to the rule that corresponding sides in congruent triangles are equal to each other. Again, AM equals to AD according to the rule that corresponding sides in congruent triangles are equal to each other. And if we define AM as Y, then AD will be also equal to Y because AM equals to AD. Okay? AM equals to AD equals to Y. So in the next step we will focus on triangle ADC. So in triangle ADC, in this triangle ADC, we know that AE is angle bisector. AE is angle bisector. Again, in triangle ADC, AE is angle bisector. So why AE is angle bisector in triangle ADC? Because of the fact that AE divides angle DAC to two equal parts, to alpha and alpha. Therefore, AE is angle bisector in triangle ADC, and according to angle bisector theorem, the angle bisector AE divides side DC in a ratio of DE over EC. DE over EC, that is the ratio that angle bisector AE divides DC. And that ratio equals to the ratio between the angle lengths. And the ratio between the angle lengths is AD over AC. Again, according to angle bisector theorem, the ratio that angle bisector AE divides DC is DE over EC, and that ratio equals to the ratio between the angle lengths, and the ratio between the angle lengths is AD over AC. Okay? But what is the value of DE? DE equals to 4 units. What is the value of EC? EC equals to X. That is the value that we want to find out. What is the value of AD? AD equals to Y. So in total we got that 4 over X equals to Y over AC. Here we will multiply this equality by AC, equation number 1 by AC. We will get that 4 over X times AC equals to Y. So here we will multiply this equality by X, equation number 1 by X, and we will get that 4 times AC equals to Y times X. 4 times AC equals to y times x. So here we will divide this equality, equation number 1 by 4 in order to get the value of AC. We will get that AC equals to y times x over 4. So in the next step we will focus on the big triangle, triangle AMC. So on the big triangle, triangle AMC, we know that AD is angle bisector. AD is angle bisector. Again, on the big triangle, triangle AMC, we know that AD is angle bisector. So why AD is angle bisector? AD is angle bisector because of the fact that it bisects angle AMC. That is to say, it divides angle AMC to 2 equal parts. The first part is 2 alpha, and the second part is also alpha plus alpha is 2 alpha. So because of the fact that angle bisector AD divides angle MAC to 2 equal parts, it defines as angle bisector. So AD is angle bisector in the big triangle, triangle AMC, and according to angle bisector theorem, the angle bisector AD divides side MC in a ratio of MD over DC. That is the ratio that angle bisector AD divides MC. MD over DC. And that ratio equals to the ratio between the angle legs. And the ratio between the angle legs is AM over AC. Because the angle legs is AM and AC, so the ratio between the angle legs is AM over AC. Okay? So we got this equality according to angle bisector theorem. So what is the value of MD? The value of MD is 3 plus 3. That is to say 6. What is the value of DC? DC equals to 4 plus X. All equals to AM. What is the value of AM? AM equals to Y, according to our definition. Y over AC. So we got equation number 2, that 6 over 4 plus x equals to y over AC. Here we will multiply this equality by AC, and we will get that 6 over 4 plus x times AC equals to y. So here we will multiply this equality by 4 plus x. We will get that 6 times AC equals to y times 4 plus x. Here we will divide equation number 2 by 6 in order to get the value of AC. So we will get that AC equals to y times 4 plus x over 6. That is the value of AC according to equation number 2, and we have already found out the value of AC according to equation number 1. The value of AC is actually y times x over 4. So we have the values of AC in equation number 2 and equation number 1. In the next step we will create equation number 3 that states that AC equals to AC. Okay, AC equals to AC, and we will place the value of AC in equation number 1 in this AC, and we will replace the value of AC in equation number 2 and this AC on the other side of the equation. Okay, so we will get that AC according to equation number 1 is y times x over 4, and AC according to equation number 2 is y times 4 plus x over 6. Here we will divide equation number 3 by y. It is allowable to divide equation number 3 by y because y is actually the side of triangle AMC. It must be a positive number. It can never be 0, so it is allowable to divide equation number 3 by y. Okay, so we will get that x over 4 equals to 4 plus x over 6. Here we will multiply equation number 3 by 6 and by 4, and we will get that 6x equals to 4 times 4 plus x. Here we will open the brackets in this side of the equation, and we will get that 6x equals to 16 plus 4x. So here we will subtract 4x from equation number 3, and we will get that 2x equals to 16. So here we will divide equation number 3 here by 2, and we will get that x equals to 16 over 2 is 8 units. Okay, so we found out that the value of x is 8 units, So EC that equals to X equals to 8 units. So we finished with method 2. In the next step, I will summarize the lecture. Actually, we wanted to find out the value of X EC equals to X, and we want to find out the size of EC or the size of X. And we know that triangle ABC is a right triangle. This angle equals to 90 degrees. And BD equals to 4 units, DE equals to 4 units. Those angles are all equal to alpha. And we want to find out the value of X. Okay, so in order to find out the value of X, we must know the angle bisector theorem. So what is the angle bisector theorem? The angle bisector theorem states that an angle bisector divides the side that it eats in a ratio that equals to the ratio of the angle legs. So what is the meaning of angle bisector theorem? The angle bisector theorem states that the angle bisector AD, first of all, AD is angle bisector. Why AD is angle bisector? Because of the fact that it bisects angle BAC. That is to say, it divides angle BAC, this angle, to two equal parts, to alpha and alpha. Therefore, DA or AD is angle bisector in triangle BAC. So according to angle bisector theorem, the angle bisector AD divides the side that it eats. Angle bisector AD eats side BC of triangle ABC, and it divides it in a ratio of BD over DC. Again, angle bisector AD divides side BC of triangle ABC in a ratio of BD over DC. BD over DC. And that ratio equals to the ratio between the angle legs. And the legs of angle BAC, the legs of angle BAC are AB and AC. So the ratio between the angle legs is AB over AC. So the ratio between the angle legs, that is AB over AC, equals to the ratio that angle bisector AD divides BC. Okay? Again, the ratio that angle bisector AD divides BC is BD over DC, and that ratio equals to the ratio between the angle legs, that is AB over AC. Okay? So that is angle bisector theorem, and we implemented the angle bisector theorem in the right triangle ABE. We know that AD is angle bisector. Why AD is angle bisector in the right triangle ABE? Because of the fact that AD divides angle BAE to two equal parts, to alpha and alpha. Therefore, AD is angle bisector in the right triangle ABE. Okay? And according to angle bisector theorem, angle bisector AD divides side BE in a ratio of BD over DE. And that ratio equals to the ratio between the angle legs, and the legs of angle BAE are AB and AE, and the ratio between the angle legs is AB over AE. Okay, so again, the ratio that angle bisector AD divides BE is BD over DE, and that ratio equals to the ratio between the angle legs, that is to say AB over AE. Okay, according to angle bisector theorem, what is the size of BD? BD equals to 3 units. What is the size of DE? D equals to 4 units. So we got that AB over AE equals to 3 over 4. Then we defined AB as 3K. That is to say AB equals to 3K. And we placed the value of AB inside this equality in order to find out the value of AE. Okay? And we found out that the value of AE, if AB equals to 3K, AE must be equal to 4K. Okay, then we continued to focus on the right triangle, triangle ABE. According to the Pythagoras theorem, in the right triangle, triangle ABE, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. That is to say, AB square plus BE square equals to AE square. AB square plus BE square equals to AE square. We know that AB equals to 3K, AE equals to 4K. What is the size of BE? BE, according to the drawing, equals to 3 plus 4, that is to say to 7. So BE square is 7 square. So we got this equality. We have only one variable that is missing, that is actually K. In this simple equality, we solved this equality and we found out that K equals to root 7 units. K must be a positive number because K is the size of the side of a triangle. It must be a positive number. So K equals to the positive root of 7. So we know that if K equals to root 7, and we have the equalities as AB equals to 3K and AE equals to 4K, we can place the value of K inside this equality, and we found out that AB equals to 3 times root K, and we placed the value of K inside this equality, and we found that AE equals to 4 times root 7. So we have the value of AB and AE. Then we focused on the right triangle, triangle ABC. We know that in the right triangle, triangle ABC, tangent 3 alpha equals to BC over AB. Tangent 3 alpha equals to BC over AB. What is the value of BC? BC equals to 3 plus 4 plus x. That is to say, BC equals to 3 plus 4 is 7. So BC equals to 7 plus x. BC equals to 7 plus x, and we have already found out that AB equals to 3 times root 7. So in total, we got that the value of tangent 3 alpha is 7 plus x over 3 times root 7. Then we focused on the right triangle, triangle ABE, this triangle. On this right triangle, we know that tangent 2 alpha equals to BE over AB. Okay? On the right triangle, triangle ABE, tangent 2 alpha equals to BE over AB. What is the value of BE? BE, according to the drawing, equals to 3 plus 4, that is to say to 7. So BE equals to 7, and we have already found out that AB equals to 3 times root 7. So in total, we got that the value of tangent 2 alpha equals to 3 over 3 times root 7. Then we focused on triangle the right triangle, triangle ABD. We know that in this right triangle, tangent alpha equals to BD over AB. Okay, tangent alpha equals to BD over AB. What is the value of BD? BD equals to 3 units, and AB equals to 3 times root 7. So BD, so in total we got that the value of tangent alpha is 3 over 3 times root 7. So we found out the values of tangent alpha, tangent 2 alpha, and tangent 3 alpha. Okay, but we also know that tangent 3 alpha equals to tangent 2 alpha plus alpha. Okay, and in order to find out the value of tangent 2 alpha plus alpha, I presented to you a new trigonometric identity of tangent A plus B. Actually, tangent A plus B equals to tangent A plus tangent B over 1 minus tangent A times tangent B. So we used this trigonometric identity in order to find out the value of tangent 2 alpha plus alpha. According to this trigonometric identity, the value of tangent 2 alpha plus alpha equals to tangent 2 alpha plus tangent alpha over 1 minus tangent 2 alpha times tangent alpha. Okay, so we have already found out the values of tangent 3 alpha, tangent 2 alpha, and tangent alpha. So we can put the values that we have already found here inside this equality. Okay, so we substituted tangent 3 alpha by 7 plus x over 3 times root 7. We put the value of tangent 2 alpha inside this here, and we put the value of tangent alpha here, and we got this equality, and we solved this equality. This is very simple equality with only one variable that is missing, and we found out that the value of x is actually 8 units. Actually, EC that equals to x equals to 8 units. That was the answer to the question according to the first method, and we also answered the question according to a second method. So in the second method, we made the construction. We extended BD, side BD, by 3 units, and we defined this point as point M. Because of the fact that we extended BD by 3 units, MB will be equal to 3. Then we join together points M and A by a straight line, and we know that MD is a straight line because BD as a side of a triangle is a straight line, and we extended the straight line BD by 3 units, so MD remains a straight line. So MD is a straight line, and we have a rule, the rule that the sum of the angles on the straight line equals to 180 degrees. Therefore, at any point on the straight line MD, the sum of the angles on that straight line equals to 180 degrees. And if we focus on point B, on the straight line MD, the sum of the angles at point B must be equal to 180 degrees. So what are the angles at point B on the straight line MD? The angles are this angle that is 90 degrees plus the size of angle ABM must be equal to 180 degrees. According to this rule, that the sum of the angles on the straight line equals to 180 degrees. So here we subtracted 90 degrees from this equality, and we found out that the value of angle MBA is 90 degrees. So this is a right angle, therefore triangle AMB is a right triangle. Then we proved that those two triangles can go into each other. First of all, we know that MB equals to BD equals to 3 units. This is according to our construction. MB equals to BD equals to 3 units. And we also know that those two angles are equal to each other. They are both right angles. We proved that this angle is 90 degrees and this angle is 90 degrees according to what is given us in the question. So those two angles are equal to each other. They both equal to 90 degrees. Angle MBA equals to angle ABD equals to 90 degrees. And AB is a common side. It belongs to both triangles. So AB equals to AB. So we actually proved the triangle AMB is congruent to triangle ABD according to side angle side rule. What is side angle side rule? If you prove that in one triangle two sides and the angle between them in one triangle are equal to two sides and the angle between them on the other triangle, then you actually proved that those two triangles can go into each other according to side angle side rule. And we actually proved that side AB, side BD and the angle between them are equal to side MB, side AB and the angle between them on triangle ABM. Therefore we proved that those two triangles can go into each other. Again, we proved that side AB, side BD and the angle between them in triangle ABD are equal to side AB, side BM and the angle between them in triangle ABM. Therefore we proved that those two triangles can go into each other according to side angle side rule. So from the fact that those two triangles can go into each other, we can conclude that those two angles are equal to each other according to the rule that corresponding angles in congruent triangles are equal to each other. Actually, those two triangles can go into each other, therefore those two corresponding angles will be also equal to each other. So if this angle is alpha, this angle also alpha. And we also proved that AM equals to AD according to the rule that corresponding sides and congruent triangles are equal to each other. Those two triangles can go into each other, therefore the corresponding sides, that is to say AM and AD, will be also equal to each other. So we defined side AM as Y, and because of the fact that AM equals to AD, AD will be also equal to Y. Okay, then we focus on triangle ADC. On triangle ADC, this triangle, we know that AE is angle bisector. Why AE is angle bisector in triangle ADC? Because of the fact that it divides angle DAC to two equal parts, alpha and alpha. Therefore AE is angle bisector in triangle ADC, and according to angle bisector theorem, the angle bisector AE divides side DC in a ratio that is actually DE over EC. Okay? Angle bisector AE divides side DC in a ratio of DE over EC. Okay, it divides side DC in a ratio of DE over AEC, and that ratio equals to the ratio between the angles legs, and these angles legs are AD and AC, and the ratio between those two angles is AD over AC. The ratio between the angles is AD over AC, and that ratio equals to the ratio that angle bisector AE divides side DC, that is DE over EC. So those two ratios are equal to each other, according to angle bisector theorem. So what is the size of DE? DE equals to 4. And what is the size of EC? EC equals to X. And what is the size of AD? The size of AD is Y. So in total, we got that 4 over X equals to Y over AC. We multiplied this equality by equation number 1 by X, and we got this equality. Then we multiplied this equation number 1 by X, and we got this equality, and then we divided equation number 1 by 4 and found out that AC equals to Y times X over 4. Then we focused on the big triangle, triangle AMC. This big triangle, triangle AMC. We know that in this big triangle, triangle AMC, AD is angle bisector. Why AD is angle bisector in triangle AMC? Because of the fact that it divides angle MAC to two equal parts. Part 1 is 2 alpha and part 2 is also 2 alpha. Because of the fact that AD divides angle MAC to two equal parts, because of this fact, it is defined as angle bisector, because of the fact that it bisects angle MAC. So, according to angle bisector theorem, the ratio that angle bisector AD divides MC is MD over DC. The ratio that angle bisector AD divides MC is MD over DC, and that ratio equals to the ratio between the angle legs. The angle legs are AM and AC, and the ratio between the angle legs is AM over AC. So the ratio between the angle legs, that is AM over AC, equals to the ratio that angle bisector AD divides MC, that is actually MD over DC. So those two ratios are equal to each other according to angle bisector theorem. Okay, and what is the value of MD? MD actually equals to 3 plus 3, that is to say 6. What is the value of DC? DC, according to the drawing, equals to 4 plus X. 4 plus X. And what is the value of AM? AM equals to Y, according to our definition. So in total, we got in equation number 2 that 6 over 4 plus X equals to Y over AC. Here we multiplied the equation number 2 by AC, and we got this equality. Then we multiply this equation by 4 plus X, and we got this equality, and then we divided this equation number 2 by 6 in order to get the value of AC, and we got the value of AC. AC equals to Y times 4 plus X over 6, according to equation number 2, and we have already found out in equation number 1 that AC equals to Y times X over 4. So we have two values, the values of AC in two equations, in equation number 1 and in equation number 2. Therefore, we created equation number 3 that states that AC equals to AC. Then we place the value of AC in equation number 1 in this side of the equation. We place the value of AC in equation number 2 on the other side of the equation number 3, and we got this expression AC equals to AC, AC in equation according to equation number 1 equals to AC according to equation number 2. We solved this simple equality. We divided this equality by y and we got this expression. Then we multiplied it by 6 and by 4. Then we divided it by, we opened the brackets. Then we divided it by 2. And we found out that the value of x is 8 units. So we found in both methods that the value of x is 8 units. The value of x that is actually equals to EC is 8 units. We found in both methods that the value of x is 8 units. Okay? Thank you very much.